Okay. We're gonna have a okay. So I think we're live. Yeah. Set up that alert, so track of this. Okay, welcome to today's stream. We are going to try to get a custom image to work with the Xilinx Ubuntu image. If not, I'm not sure if we'll be able to do Vitus AI on Ubuntu, but this is kind of our Vitus AI thread. But we'll see how it goes. Okay, so first we're going to add the we'll do LEDs. Oh, we gotta run blog on it. Board presets. Oh, they're important. The connection automation. Wait. And dip switches. Yeah, GPIO2. Boom, boom, boom. What are you wanting? Sure, you can have that one as well. No interrupts. Okay. We're gonna save. We're gonna validate. So we're creating a simple zinc image here that has the LEDs and the dip switches connected. And our goal is to read and write from Linux address map. Yeah, hey, sounds great. That's the base address for that. It should be open. So yeah, let's go ahead and slap a wrapper onto that. Get that building. So that should work just fine. My camera is still very off. Okay. Feel like center a little bit. Okay. Yeah, still too high. Okay, that's much better. Okay, we got top level, so we're gonna go ahead and generate bitstream. So while this is generating, we are going to try to figure out more about these snaps. So we looked a little bit into this last time, but we may have to figure out how to get the Xilinx config to work. Um, um, that's it. Okay. Okay. So basically, what we got is a bunch of nothing. Um. So let's see if we go to the ls/boot firmware. Um. Nope. So so let's do boot firmware. Gonna boot files, image files, network config, user data, CPU user. That apparently not a directory. Okay. What's this? Okay. And boot files. No, I don't. Generating these files is going to be hard, and I can't generate them with. I have to use Petalinx, I think, right? And generate a DTB. Well, let's just see if we export the XSA file. Does the XSA file have these things? It would be cool if they did, but I don't think they did. Do. I guess we could try to open this and buy this and see if it works. Okay. It's a different project. So let's go. Okay. So here we're running that quickly. We'll look at what the XSA file has. So we're gonna try to just do this through JTAG real quick to see if that works. Vivado is really bad at canceling things. Okay. This should not take too long at all. Doing a very simple. Okay. Yeah. So we can use. We're gonna use JTAG to eventually get into this. But cd/snap. Yeah, here we have bin core snapd. What's in snapd? Current. Is there anything we can look for in here? I don't think so. Bunch of stuff. Nine in current. What's the current? It's just 9. Snap. Snap inside the snap. Hook manifest. User. Then activate Python 3. Okay, and that includes lib Python meta hooks. Yeah, still nothing useful in here. Okay. Trying to figure out how to bootgen biff file. Makes sense. I don't see any problem with that. Important files and directories. We've been there. Been there. So cd user share Xilinx similar. We got here cd VCU104. We got we have a biff. Oh, look, we got files. Can we make this? We should make this a folder and see if we can make this a config and just change out stuff and maybe do a DB editor. Okay, so yeah, I have files. So where do you want me to copy them? So I don't have a manifest YAML. Okay. Um, okay, in this example, so where should we bring these files? I think we should do these into user local, or we should do it into that file. So yeah, I like where this is. So we're gonna go to cd/boot firmware, right? We're going to make a directory Xilinx config. We're gonna make a directory Xilinx config. And then we're gonna sudo Xilinx config sudo pack name. In this situation, they create test.pack directory. cd test pack. We're going to, I guess, sudo make directory hardware config. Yep. Um, hardware config. We're gonna sudo make directory. And you know what? I'm tired. We're just gonna super user this. Why so long? Thank you. Cool. So now we'll just do foo, right? Make directory foo. Sense. Um, I'm a super user. Okay, whatever. Cd foo. We're going to we have vim, so we're gonna sudo vim manifest.yaml. Really do this. Else inserts. Copy. Oh, um, uh, so we have a manifest YAML file, and now we're gonna add the ZCU1 folder, sudo make directory ZCU104. Okay, yeah, let's what is it? Oh, if config. Um, how do we determine the IP address? Sudo apt install. Thank you. Okay. Cool. Let's see how this is going. That window now. So this is good. So remind me later. So what we're gonna do is we're gonna export the hardware. We're going to do include bitstream. We're going to do top wrapper XSA file. Yes. Finish. Then we're gonna extract that file. Um, so we have this XSA file. What we're gonna do is we're gonna copy it. We're going to go to rename. We're going to rename it. We're gonna rename it to a good old zip file. Zip. Yes. And we're gonna extract it. Okay. So we get anything of use, do we? Apparently, oh, that stuff's not gonna help us. Maybe we can generate some of the files with okay. Uh Here we go. If config ETH0 is 1.8. Let me pull up that. Let's get the camera going. SSH the SSH Xyl no Ubuntu 192.168.1.8. Nope. Unlock. 92.1.8.18. Oh, why so long? Okay. So we're still going to boot firmware. Xilinx config. Boot. So what we're going to do is we're going to copy everything from this directory and rename it appropriately. So we want to sudo copy. I mean, probably just mod dash r77 star. Oh, is it 77 star? Sudo. Sudo. This. Alright, so cool. So we're going to copy the files from user share Xilinx firmware ECU 1.4 star here. Sudo. Okay. Okay, cool. Here we have the files. Now we want to rename it to match this configuration. So, we're going to move the ECU 104 boot gen to boot gen.bit. I don't understand. Okay, cool. We're gonna have to do this for everything. ECU 104. There's we got what we got for ourselves. PM do that. PMUFW.L. Well, let's do a first stage bootloader. We do ZU Zinc. Zinc first stage bootloader.elf. And what we're doing next, we are doing system.bit to system.bit. System DPB ls. So I think everything is correct. Let's go ahead and rm this GPU. So bang bang. Okay. Now we did that. Snap installation. This is manual installation. Snap. Boot assets to do activating the platform. So now to do Xilinx big Q. We have a dash Q. Sudo bang bang. Okay, it's not accessing as my asset folder. Why is that not my? Um, okay, where are we putting these files? I'm So confused. Data. Local firmware, Xilinx, manifest. Oh, how I put it in the correct location. Right, so boot firmware, Xilinx config, star, hardware config, star, manifest.yml. So is this correct? Manifest.yml. If I cat the manifest.yml, it's probably gonna be sudo because it hates me. Okay. So what are we doing wrong? Um, can I do -A? I have to like go like boot firmware, Xilinx, manifest. Um, Maybe I have to install it and then do a hard reboot of it. So yeah, we'll have to figure out how to get the bit file in there. Maybe get a DDP tree editor. I didn't need to be that way. Do we have pedal Linux on the farm? Um, pedal Linux. Yeah, 22.2. We can maybe move the XSA file over or generate it on this side. I'll have to think about that. Let's see if we can get the thing to work. Ubuntu. So long. Okay, let's kill the where was that? Instruction. Do right here we want to copy. Why so long? Free this up a little bit. Xilinx query. Did not see it. Um, so we did it. CD user local shared. Um, let's just copy cursively boot firmware Xilinx here. sudo bang bang ls. So if I do query now, still not seeing anything. Okay, you manual install, you do not work. Let's see. Let's go. Um, um, yeah. We have devman here. Uh, Ubuntu dev. So sudo apt. Oh, okay. Back here, we did the query. Okay. You're not seeing anything. Did we install it today? Um, um, boot firmware. Config test pack, hardware config. Like that's what it's called, right? Oh, yeah. Someone made it. Oopsies. Okay. So let's go there. cd/boot firmware is that config ls test pack. You want to move hardware to hardware sudo bang bang. Query. Okay. So we have something right here now. Do we have devmem2? Devmem2 to and the address we want to read 4 is that map that um okay, so apparently that is that way. Okay, so now let's load in this other bit file. Um, so we go to bring up this guy. Um, where's foo? Um, so let's bring in our GPIO1 implementation. Wrapper.bit. Okay, let's go home and move it. Home, Ubuntu. Yay, top wrapper.bit. Okay, so cd /boot firmware config sudo. We want to sudo move copy wiggly top wrapper system outfit long and Xilinx bigger Q let's FD sudo bang bang. Please reboot to take effect. So we're gonna reboot. Sudo. I need to put my in okay. Go back here. So we've loaded the file, we've got the system to recognize it. So what's the hardest part now? The hardest part now is so if we go back to the files we were using, right? So if we go back to the files we're using here, we have that's not going to change, 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 that will change, and this will change depending upon what we want Linux to load up for it. So what we could do is generate this. We could try to move the XSA file over to 2021 dot or 2020.2 to see if Linux can handle it. That might be next week to get Linux building with this. Where is it? Okay, so Xilinx. Let's activate boot. We're doing test. Boot. Okay, so it generates this boot binary. Updating multi-bit register, important reboot for change to take effect. Sudo reboot. Try again. So now we have, so now we just want to test that. So we have a GPIO right here, our AXI GPIO with LEDs on channel 1, dip switches on channel 2. We have our address of A0, and we'll see if devmem2 handles it well. So let's go back here. Where is it? Ubuntu DTB enter. Very far away to okay. Why so long? Yeah, pretty cool. Sudo dev 2 A00. Cool. That is so that is not reading the right addresses. We're having a value mapped issue. Um, hmm, hmm, hmm. Um, 1, 2, 3, 4. Uh, so that's not the right address. Ubuntu read raw. Oh yeah, let's just okay. So we want to cat specific line in file. Use SED. Um, okay, so cd slash dev. There's mem in here. Oh, that's a lot. Um, let's open this in. Okay. Um, cd slash dev, and there's a mem in here, right? We got mem. So if we can't mem, it's gonna be really long. So let's just tail mem, right? So, y. Uh, yeah. Not committed. Uh, cd. Um, I don't want to do this in Python. Sudo Python. I know there's Python. See Python 3.8. And there's no Python. Cd slash bin. Plus, I have a Python. The snap. Big. Right. Bin. Plus. Um. Great. Okay, so we're in Python 3. Um, we're going to map. Oh, we need to. He said memutil. Um, let's zoom out. He said. Okay, so quit. Quit. Um, we're gonna need sudo this, and yeah, we're going to copy that, paste. Okay. Oh, numpy. Ooh, that's gonna be rough. Hmm. We won't worry about that right now. Let's look at Yeah. Well, that's Notepad plus plus. And we're gonna do offset is right, 3, 1, 2, 3, 4. Size, it doesn't even um paste. Oh, so uh, paste. Um, so uh, Python mmap. So yeah, let's do mm.seek. No, m.seek. Okay, cool. We don't want to do. Don't want to do read line. Just do a no read. So we're just going to read for read. Okay, so EADE. These are the GPIO switches. So let me find where these GPIO switches are on the board. In the first, where are the GPIO switches? Those are the mode pins. Oh, here we go. It's hard to tell where the user LEDs are. Okay. 16. Um, 1, 2, 3, 4. 1, 2, 3, 4. And that does not look right. It looks consistent, doesn't look right. So let's pull up. We're gonna break. We're probably gonna break this system. So we're gonna pull up XSDB, connect, make break the Ubuntu targets. So we're gonna say targets 8 in this situation, right? And we want to do a memory read of A123, 1, 2, 3, 4, and we want to do 4 of them. Uh, 9. So translating it, I need why did you do this? I don't want translations. Why is there no power to these ones either? Or is powered down? Okay. How do I know what values I expect? Okay, let's program the bit file at least, right? Where are we? Oh, this is gonna be great. So C slash accept slash green slash what? Deal 1 IO directories ZCU 1.04 DIO dot runs cd1 cd implementation 1 and then we have FPGA dot chef top graph dot bit. So we changed the bit file. I am really trying to figure out what's happening here. Read. Okay, that is correct. So we had the wrong bit file. Dash Q. It says it's activated. Did the bit file not load properly? Okay, so that's the correct value. How about what's dev mem to say at X, okay, 1 2 3 1 2 3 4 sudo. Yeah, that's right. Um 4. Uh um so I'm gonna say 1 2 3 4, say a word, and go like, oh, oh. Uh, so we can get it working with that. Let's go ahead and back to the Python real quick. Try again. Sudo Python, Badoop Badoop, in our little text file. Paste. So mem.c 0 mem.in. Okay, so we need to do we need to do? PIO wise, add configuration, all outputs, all inputs. Still think we need to change the tri-state, right? Okay, so tri-state, which is inputs. Tri-states. 0. So it's a high, it's input. Oh, right here. There we go. This 3, that is our lower bits. Okay, so we have 4 LEDs, right? LEDs, 4 bits. So if we go back to seek, right? And we go back to right, byte. And we just write byte, and once a byte. So b slash x 0f, like that. You clearly do. I don't want to write. So, oh, I see the LEDs. They came on. So let's write A0. Data outrange. Oh, got it. Seek. And then write 0. Okay, we can turn on and off the LEDs. Okay, so that's weird. From what I can tell, we did not load the proper bit file. Here, firmware, Xilinx, power config, zoo, ZCU 104. Let's go check. Oh, is that me? Typo in bytes. Oh, you're right. Still work though. So let us figure out why we are having a issue with. Did we get the wrong bit file in here? How what happened? That's back card we can do zoo. Right here. We have a system.bit. ls dash la. What we got here? The system.bit was generated the 5th November 30th, 504. And if I do a ls la of squiggly 503. So those look like the same bit files. Why was it not loaded? When we activated it, go back that far, right? When we activated it, where we that's us deactivating it. Then we activated it right here, generating a boot file here, multi-boot register, CPU. Is it somewhere listed in here where the boot file is? Loading image fit device tree, booting Linux on CPU. Where is it loading the bit file? I want to know. Okay. So from what I can tell, that is not working. So we try to activate it again. That's one dash two. Already activated. Um, um, boot file. Can we see if we reboot, sudo reboot, if this actually loads the correct file in? So yeah, we'll see if this loads the correct one. Then we're gonna try the Xilinx util. Looks like we had a bad exit code. Eh. Did our SD card get uh okay. Well, back here, copy, copy. Okay, so now we're going to sudo /snap filing bin current bin icon. Okay, and going to our predetermined, we paste this, yes, mem.seek 0, mem.read 16. That is wrong. Okay, so let's open up another window, right? Why? So long. What we're gonna do is we're gonna try using one of Xilinx's other tools, right? So they have this FPGA manager, right? FPGA util, FPGA util-h. Bin file. We can do a bit file too. So we're gonna do a -d top wrapper. Sudo bang bang. So long. Okay. It took a while. That's an appropriate time. Now we do a seek. Okay, now that's correct. So I can load it through FPGA util. That's good news. So I can't get their snaps to work properly. Let's go back here to how they do it. Sudo reboot now. So it's just active. I don't. Does that mean like we're doing that TTP then instead of the other one? Not happy at the moment. Okay, explain to me -i. Okay, so let's go Xilinx -i. Detected argument. Check whether you as it's active. We could try active with a -f to force it. I mean, like that's like all we can do. Um, okay. So handling a boot asset, run as inputs. Clear. Copying the file to boot firmware. This has default boot assets. So we go to cd var lib config ls. What is active? Or boot Xilinx firmware at Xilinx. So it's just saying that's the active board. Okay. Okay, so I don't know. This is we did it correctly, but it's not loading correctly. So I mean the only thing I can think of is if we go here and we do Xilinx config -a -f test platform form dash foo expects you want what dash f sudo bang bang. I want to see this work. So let's just verify that bin right quick. So we had this FPGA util, and I go to boot firmware, right? And I do boot at 1040 bin. Sorry, was that not clear enough? So we have an IO error. Well, let's try again. Let's try copying that beautiful file. So copy that boot firmware boots 1040 bin to here, right? So this must be a binary file like instant boot. So sudo reboot now. This is the only thing we really can do. We had an issue. Where's this? Oh, because we changed it, we forcefully changed it. Not happy with those. Maybe it's because we have a bad DVB and it's not working properly. Yeah, that's the only thing I can think of. We're corrupting a DDB and it's not happy about that. It doesn't tell me which bit file is located where. So the only next step I can think of is that we use Petalinux to create a DDB of this image. I just grab the DDB in the Petalinux directory and copy it over. Or use DTS. So let's go ahead, let's go back here, right? Let's go use this. Well, so Linux. Um, paste. We're going to do boots firmware. Like view, view, system. Um, us. That is, so let's see. Probably breaking a lot of things there on different addresses. They have, let's see. Yeah, they have a lot of things in here that I clobber. Yeah, it's all inside the design. See, that's on the bus. That's on the bus. That's on the bus. On the PL. So yeah, I think we would just have to write our own DTB file. I guess we can do that in Linux. Yay. So yeah, I think that's it for today. Feel free to look back. Oh, I want to capture one of these. Where's the file mode? Okay, refresh. I want to down. Sure, we'll download it. No, not to that one. Right. Stream. To yeah, like a 5 RGMII. um, where's the 5? So yeah, I think that was the only file I was interested. Yeah, we want to do looking for PHY mode. Um, okay. Yeah, nothing special. Okay, I think that's about it for the day. Thanks for watching. We successfully put a broken, we put Bitstream on here. We could access the values through Python, read and write the switches through Python. But we couldn't use their Xilinx config feature. The only thing I can think of is if we have to regenerate the DTB. And we could look at, so another thing we could look at, so we can learn how to generate a DTB, which shouldn't be too hard with Linux. And we want to, we could do that and match the, it's optional. I'm not sure how optional it is at the moment. Did not match the country in the bitstream. Okay. Yeah, so I guess next Monday we will look at doing that. We'll do Linux build with the GPIO, throw the Linux build and see what happens. We'll go through that stage of Linux. We'll bring down the example Linux they have and then just copy over the DDB that we generate. Oh. Yeah, that won't be too fun. But yeah, yes. So 2020.2. Okay, thank you for joining us today. It's not terribly interesting. I was just playing around with Ubuntu image. It seems kind of worked, kind of not. Hopefully we get somewhere in the future.